I'm not quite sure where it come out as it's not yet too. Oh, it's too much. Some people say it's mostly.
Okay.
Yeah.
All right. Let me change the angle here so the people online can see my glorious visage. The right angle. All right. Sure. Yeah.
Tim, you do the introduction.
Thank you everyone for coming. Today we've got a guest speaker who's on holiday. He's taken a sabbatical. He's been doing a lot of work for Google.
10 years. Yeah.
Google Brain and
DeepMind.
So that's been a really interesting place to work, I imagine.
Yeah.
It's great that he's come back to UW. It is electrical engineering and computer science degree.
Tim was my coach and Wei was my honors co-supervisors. Yeah.
So today he's coming mostly as a casual presentation. Questions. Just going to tell us a bit about stuff.
Cool. So it was actually kind of challenging creating these slides because I didn't have a good sense of what people here would be interested in or like what they're working on. So maybe just as like a show of hands, maybe if you're online as well, like who here is an undergraduate student? Okay. Who here is doing honors? Okay. Who here is doing honors for CS degree? Okay. And who here is a PhD student or a fellow or something like that? Like you're not. All right. Cool. Oh wait, what is happening? Was that sound for me?
Someone take care of that.
Okay. Cool. Who here is actively either honors or for PhD, actively doing something involving LLMs? Okay. Oh, everyone. Okay. So what kind of stuff? So by the way, while I'm talking, just like interrupt me. This is like very casual. My general plan was to just like talk about who I am, sort of stuff I've done, where I think the market is, where I think it might be going. But I kind of wanted it to be, I guess the vibe is like when I was in your shoes in a much less nicer version of this room around 12 years ago, these sorts of conversations were really helpful for me to kind of humanize the process of not being here effectively. And so I'm happy to do that. I'm happy to pay it forward in that way. And so just like interrupt me, raise your hand, whatever, get my attention. And my general plan was to kind of just walk through a bunch of ideas that might be interesting, but I figured most of the meat or the juice of value for you guys would be in the Q&A. So we can talk about whatever we want to talk about, and I'm happy to make myself accessible in some sense after Q&A as well. So so I can kind of riff more effectively on these slides. Does someone want to like give like a word constellation salad of like what sort of things people are working on, like what sort of things you're researching? Like, do you want to talk about, sorry to pick on you, but like what are you working on? Okay. Cool. And how you raised your hand when I said who's working with LLMs? What are you? Cool. Does anyone else want to share what they're doing so I have a better sense of who I'm talking to or what you might be interested in? Maybe one of the postgrad students, your research agenda, what your latest angst from review number 2 is. Yeah. Pick on people. Well, Colin, why don't you go? Because maybe it'll be, yeah. No, No, so you can be our
So,
tribute, you know?
Yeah, yeah. So in terms of, I don't know, I was looking at one point with how different types of different ways of phrasing inputs affect the accuracy of diagnostic or medical chatbots.
Yep. Cool.
Yeah.
What about, do you feel comfortable sharing? Oh, cool. Cool. What's your research agenda? Okay. Are you working with Wei? 'Cause I don't know if Wei is still working on LLP or. Oh, I'm just making a lot of assumptions here. I know I worked with Wei like 10 years ago or 12 years ago. Um, gotcha. 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 Do folks at the back want to say a bit about what they're doing if you feel. Okay. Okay. Sure. What about you? Okay. Okay. Oh, cool. Cool. What about you? What kind of events? Okay. Okay, that's cool. For the folks that just came in, we're just sharing what we're all working on, so I have a better sense of. I don't know how much context you have of my background or whatever. If you feel comfortable sharing on what you're researching, or please feel free. Okay, cool, cool. What about you? Okay, so like, sort of like, well, by information seeking, you mean like using a search engine as a tool or something like that? Okay, okay, cool, cool, cool. Is there anyone remotely that wants to chime in? If not, I think I have a better sense of who the crowd is, so I can kind of adjust on the fly. Um, yeah, yeah, yeah. And during the talk, just unmute yourselves and make yourselves be heard if you wanna interrupt. It's like we don't have to put people on the spot. It's fine. It's fine. It's fine. But thank you for everyone who participated in my little game. Okay, this is actually helpful. So I'll okay. So let's see. Okay, so like I said, I didn't have a perfect sense of what to talk about. Maybe I can talk a bit about just who am I? Well, kind of like what Tim said. I used to sit, like I said, in a less nice version of this room doing Math 2040, I believe. I don't know what it's called now. That's the one with the multivariable calculus. There were tutorials for that in here. I think I did it with you actually.
No, I think I skipped that one.
Yeah, maybe. Yeah, but yeah. So I was here and it's what it's called what? Interesting. Okay, there you go. So I did that. And so yeah, my honors project was with Wei and Roberto, who you mentioned is retired now. Um, Oh, interesting. And yeah, I did ICPC competitions with Tim, Luigi Baroni, Rowan Davies. They were coaches. And after I graduated, I worked in the Google Sydney office for a couple of years. And then after that, I went to the US for where I've been for the last like 8 odd something years, and my time was pretty evenly split between the Google Brain team and DeepMind team, which Brain as a team no longer exists. It got merged into DeepMind, but at the time they were doing deep learning research, and yeah, I mean it was I kind of I'm also happy, by the way, to talk about like career stuff if that's useful, of how to get an industry or like job or whatever. My sorry.
How do I get a job?
Well, we'll do the questionnaire at the end, but yeah, we can talk about that. I think yeah. So I will say, if you are doing interview questions, one of the highest ROI things you can do is to do the ICPC competitions with Tim, or I don't know if Max is doing it now, or you're still doing it. Yeah, shit. Yeah, there you go. Then this guy, talk to this guy, and that is actually really good practice for interviews and just general problem solving, especially if you're like in your second year or first year or like early on. This is like a really good investment you can make. And yeah, so my pathway into deep learning was pretty idiosyncratic in that around the time I got in, the getting in was kind of good, and the AlexNet paper had just been published, and I had a GPU and I had a bunch of time, and I was actually doing an electrical degree, so I convinced Roberto to let me do a CS honors project, and Wei agreed to co-supervise, which made it possible. So yeah, like it was pretty idiosyncratic, but I'm happy to talk about that. And so the sort of stuff I've mostly worked on is back in the day working on various sorts of medical imaging projects where we trained. No one really uses residual networks now, but training various sorts of convolutional networks to predict interesting things from medical imagery. Specifically, I was a co-first on a Nature paper where we made a superhuman mammography model. And at the time, and it's still true today, deep learning was an extremely alchemical thing to get involved. It's kind of like you just like that XKCD comic, swirl the linear algebra until it starts looking right, you know? And so some of my co-authors and I, we published a bunch of playbooks, including the deep learning tuning playbook, which we made public, which attempted to systematize that process. And um, after all that, I was looking for change, and at the time, LLMs weren't a buzzword, and I was looking for something cool to do. And a friend told me, sequence-to-sequence modeling on generating code is probably going to be interesting. And it ended up being very interesting. And so once after ChatGPT, the Gemini team was formed, and I was a core member of that team right from day zero for a couple of years until I quit to do my sabbatical. And so today I was mostly during the me talking at you part was going to talk about how deep learning has changed over the last like 10 years, the implications that might have for industry and academia, and what value creation looks like in this new world. And I think I also really want to caveat here, these are my opinions. These opinions for you right now are free, so take them for what they're worth. And which right now I'm giving to you for the price of zero, right? So like think critically about everything I'm saying, and these are just my opinions, right? That's right. Whatever that means. And so yeah, when it started, deep learning, was kind of like this thing, especially like when I graduated, there were only really like 3 academic labs that were powerhouses, 3 or 4, like a handful of them. I don't want to start controversies here, but there was just a handful of them, like Montreal, Toronto, NYU, Stanford, that were powerhouses. And the real breakthrough happened when Ilya Sutskever, Alex Krzyzewski, and Jeff Hinton published AlexNet. I don't know if you can see the cursor. Yeah, this architecture on the left, which smashed this large computer vision benchmark called ImageNet. And that was really, there are different points you can say when the deep learning revolution began, but that was like a high point, which like caused a lot of industry participants and a lot of researchers to believe, oh man, there's a there, and spurred a lot of investment in this. And I have this screenshot of a TensorBoard training run from the TensorBoard website. You may or may not know what TensorBoard is, but it's really just like a monitoring tool. But back in the day, deep learning was this incredibly alchemical, empirical things. You had to like look at a whole bunch of curves to figure out what the hell is going on. And it was mostly like just like gazing that's like, I think this needs a slightly different learning rate, or I think this architecture should be slightly different. And there was a method to the madness that you mostly learned by just training a whole bunch of models and getting an intuitive sense of how the hell you were going to get them to fit to the data. In comparison, the world today is just very, very different in the LLM world, right? Is like in the past, you might have needed someone to like, carefully collect this massive data set, fit a model to it, do all this work. And now I was able to copy and paste this image of Sam into ChatGPT and ask it to giblify the image, and it spat it out in like 20 seconds, right? And so there's really been a profound change in the accessibility of quote unquote intelligence, in our ability to wield it, and our ability to use it, and our ability to deploy it, and all of that work that used to take, a bunch of people to sit and train these models has just been replaced by just writing clear English or whatever natural language you want to tell the model what you want it to do, which is, it's really difficult to appreciate how profound that is. It's like, to me, sometimes it feels like going from assembly to having an iterative programming language, an imperative programming language to kind of do stuff in. And so, furthermore, what seems to be changing is that, like back in the day, I wanted to put more charts here, but back in the day, if you looked at the performance, like ImageNet is one of those benchmarks I shared before. If you looked at the performance, like the top one accuracy on ImageNet or something like that, it was changing fast year over year. But models trained on ImageNet or even computer vision models were fairly kind of obscure in the sense that you couldn't immediately monetize them, you couldn't immediately deploy them and extract useful industry value out of them. They were still very much a research problem. But what's crazy about these LLMs is that, yeah, you can just ship them by calling an API, like a REST API. But moreover, the rate at which they're improving is just astonishing, right? So I got this slide from a tweet Noam Brown made. Noam was making this point. Codeforces is this eval of programming problem competitions, kind of like, some of the ICPC problems you might study. And you can see how the ELO scores of these models, they're like just off the walls, like up and to the right. And at the same time, this curve is happening not just for code generation, but pretty much every single cognitive task that we have a clear benchmark for. I would almost say that there's almost this case where the underlying capabilities of these models far exceeds the collective ability of humanity to create benchmarks to evaluate them and hill climb on those evals, right? And at the same time, MMLU is this academic benchmark, sort of like multi-choice questions, I believe. And if the point this slide is making is that if you look at the cost of running inference for that fixed capacity, it's been falling off a cliff, right? And there's seemingly no end in sight for both this curve going up and to the right of capabilities, and this curve going down and to the bottom in terms of cost of inference per million tokens, right? And my suspicion, this is just like a personal, like gut thing. These curves are probably going to continue for a few more years. There's like just that's just my gut feeling is we're going to see like eventually it'll probably sigmoid, but at least I think we're still a few years away from that kind of tapering off, right? And so that's something I wanted to talk about, is that, like, what does that mean? What does that mean for the people in this room? What does that mean for the people not in the frontier labs? What does that mean for people that are consuming these models, right? And so there are many lenses with which you can view what an LLM is. But for the purposes of this conversation in this room, my preferred lens would be that an LLM is kind of an arbitrage of ML talent. And what I mean by that is, let's say, for example, I have an industry problem of some sort, right? Like, let's say I have a bunch of oil well data, or have some other data set, some geological data set, some other time series data set, right? What would this look? What would this have looked like in the old world, right? In the old world, you would have had to collect a large corpora of training and email examples. You would have needed to hire maybe 2, 3 people to create the evals, to create the training sets. Once you have those things, you would have needed to have paid them to do effectively research to fit some deep learning model or whatever to the data. It didn't even need to be deep learning, some model to the data, make those determinations of which model they should pick, do effectively research on iteratively fitting that thing to the data distribution. And ultimately, it would still be this very empirical process, and you wouldn't know if you were going to succeed at creating a model that was good enough that you would be able to ship or make money off or create some actual business value on. And maybe it would have taken you a few months just to get the initial results, right? Set up the PyTorch pipeline, set up the like Apache Spark or whatever pipelines to clean up the data. In today's world, what you can just do is you can create an eval. Maybe you don't even create the training set. You create a small eval. You shove a prompt onto the eval, and you get a number. It spits out a number of how good the LLM is. And if the number is good enough, you just ship it. And instead of needing like 3-ish people over a quarter to do all of that work of running experiments with PyTorch or JAX or whatever, you needed one person who maybe actually doesn't even know that much ML. They're just very empirical in how they work with the eval sets, and they don't do really silly things about putting eval examples in the prompt or leaking the eval in various ways. And it spits out a number. And if your task is in distribution to what the existing LLMs are trained for, it'll probably be a pretty good number, actually. And in that sense, that's what I mean by an arbitrage, because if what you want is to ship intelligence, you don't actually need all that human labor to kind of make it happen. You just need to make a couple of REST API calls, even for something like data cleaning. Like, let's say you have this data set and you want to collect labels from that data set, so you create a bunch of regexes or whatever. Like, let's say you're working with de-identified electronic medical records or something. That's a lot of work. Instead, you can just write a prompt where you run in batch inference over the data set and ask it to spit out well-structured JSON that you can parse and extract exactly what you want from the data set, and you could probably do it in one afternoon using Cursor, right? So this is an extremely profound change in what it means to do machine learning effectively, where the vast majority of humans just no longer need to train models for many, many use cases to achieve business value. And that is only going to compound over time as the base models continue getting better and better and better. And so if we kind of go back to kind of this chart, a question that all of us should be asking if we don't work on training the actual frontier models is, what does it mean for us, for society, for how we can create value when the marginal cost of generation effectively starts falling to zero, right? Let's say you have like a project you want to do, maybe an assignment or whatever. Like, let's say someone asks you to make like a web app, like a card app or whatever. Maybe right now, or let's go back 6 months ago, you have to like iteratively prompt it, and it's kind of expensive, where it's not worth you like paying a Frontier Lab $10 to do it. But what if we quickly reach a world where the model is sufficiently strong agentically and sufficiently cheap that for 10 cents you can just unleash Claude Code on your specification, come back like 20 minutes later, and it's more or less just completed the assignment, and you prompt it and touch it up, and it's done. And if that capability is uniformly available to everyone with a credit card, what does it mean for how do you as an individual create differentiated value in that world, right? And so I think this is something worth pondering if you're sitting in this room right now, especially if you're studying computer science, is what does that mean for how you as an individual are going to continue creating value? when the cost of inference continues to fall by each order of magnitude, and the benchmark lenders can continue to compound pretty aggressively, quarter over quarter, year over year, right? And that's not clear. And it's not clear, like with every power of 10 reduction in cost. It's unlikely to be a very smooth and differentiable cause-effect relationship with all of society. It's actually likely to be extremely discontinuous, right? Where once you reach a certain clearing price, it suddenly becomes worth it to automate a bunch of things that you might not have automated before, and so forth, right? And so I think the pressing question for people, you know, working in machine learning, sitting in this room, studying computer science, is what does it mean to create value in a world where these curves continue to go up and to the right and bottom to the right?
If you
Yeah.
were to work with like different data,
Yeah.
do these curves still fit the same exactly how you?
Yeah, so I don't have those curves on me, but I would conjecture. So I would say, so this is my opinion. This is my opinion. Right, right. So this is my opinion. I think that almost all machine learning problems we typically deal with, whether they are image, whether they are video, whether they are text, whether they are audio, benefit from scale. That is a thing we have learned again and again from deep learning research. Rich Sutton actually wrote a beautiful essay called The Bitter Lesson, which I can send to Pascal and he can link out to you. I think it's worth reading. The way I would parse these curves is, to me, suppose we go to some specific image use case, right? And you plot it and you get something like this, right? This part of the curve as opposed to this part of the curve. My interpretation would be to ask, has someone actually tried to scale up this workload? If not, then you are actually probably just very early on in this curve. And if someone has tried to scale up this workload meaningfully, like they've shoved a lot of data into these models and not gotten the curve, that's really interesting. But I have yet to see an example. I have yet to see a domain where you don't get this kind of curve that of course eventually sigmoids off, right? But I think this is a much broader and more fundamental curve than just for code forces. I don't know if all use cases fit this curve today, but if I were making a prediction or if we were betting money on it, I would say that in the absence of other evidence, most use cases or all use cases will probably fit some exponential curve like this one that caps off sigmoidally in the presence of scale. Does that make sense? And then for all of them, they all likely benefit from falling inference costs. Because the model, for example, you might have, let's say, you could have a use case of discriminating between cats and dogs, and a use case between cancer versus no cancer and some imagery. Maybe cats and dogs are pretty saturated, and you've gotten like perfect performance, almost like human level performance. Maybe on some other task you haven't got human level performance. Maybe that's because there isn't as much data. On the other hand, the extremely profound thing about LLMs is because they're centralized onto a single model, anytime you get cost improvements somewhere, you get cost improvements everywhere, right? Because that same model is now substantially cheaper to run. And the more demand that the model providers, like the more people want to run inference with the model, the more rational it is to, as an engineering problem, make the models cheaper to run, right? Because there's more inference you want to do. Does that answer the question, John? Yeah, thank you for the question. Please, people, just interrupt me as I'm talking. So yeah, so this I would argue, as you are doing your research projects, as you are thinking about your jobs after graduation, as you're thinking about it, I would really invite you to grapple this question pretty seriously about what does it mean to create value in this world where these curves are going to be moving in this way year over year, especially if you're a computer science student. So I think that this is kind of like what I said before, is that I think that with every, you could say 10x, 2x, whatever power of, like, whether every order of magnitude reduction in the cost of inference, I think is likely going to have a pretty discontinuous economic impact in terms of what is possible to automate, what is worth automating, what is good enough at kind of for automating. And so what I would really invite you as people in this room is to grapple with the fact that every problem has a why, what, and how, right? We don't just arbitrarily do shit, right? I mean, we can, but that usually doesn't always end up well, right? And I think what's interesting is that as engineers, speaking for myself, when I was sitting in the seat all of you were sitting in, so much of engineering study and theory and training is around how we actually solve the problem. Even the exercises we often do, right? Like, do you still have to do, if you're an engineer, introductory mechanical, electrical, whatever classes? So who's done like free body diagrams or like whatever, or done like, where Tim give you homework of like, oh, write a program that meets these unit tests, and based on like the correctness on my held out test, this is the mark you're going to get for the exam. Is that still a thing that people are doing? Right. So most training that we see for engineering, which is very different, especially if you're in industry or in the real world, or if you're a researcher, the why and the what is abstracted away from you. Someone gives you a problem with some underlying motivation, even if the motivation is convince us you can do the thing, right? And you do the thing, and there is a clear right answer for the thing. And if you don't get the clear right answer based on the framing of the problem, you get dinged in your assessment, right? Which is all well and good for convincing people you can do the thing and accreditation and getting a job. But what's increasingly going to happen as these models become more and more sophisticated is that, especially in the world of bits, in the world of software, in the digital world, the generation of how will become increasingly commoditized as these models become more and more capable, as these models become cheaper and cheaper to run. And so this idea of, oh yeah, let me just give you this assignment and can you meet my hidden unit test? This is, I mean, I would argue this is already pretty meaningless, but this will increasingly become meaningless because it's sort of like mental maths. Mental maths is useful. I can't for the life of me do it. I've never in the real world ever needed to do mental maths in the last 10 years. I always have my phone with me. I do it, use it for everything I need. Does that make me probably cognitively less flexible? Almost certainly in certain ways. Does that make me faster at solving other kinds of problems? Possibly, it's overdetermined, but every problem has a why, what, and how. And increasingly, what will happen is the how will just become flattened and commoditized increasingly. And you already see this when, like, you just get Claude Code to do your assignment for you. It'll probably do a bang up job if you give it a good enough specification, and that's that. And then the machines will increasingly figure out what they should be doing. This is kind of like I would parse where like agentic workflows are kind of going where you like kind of frame a high level why for the problem, and the models themselves decompose the problem into sub problems and start generating code or generating documents or whatever to start solving the problem. But they will increasingly learn to figure out what, because once you have a why, like how has the domain of how, once you frame the problem, often has a clear right answer. What is still kind of nebulous, and it doesn't always have a clear right answer. It's more normative, right? It's like certain decisions in an engineering problem are worse than others, but you can get a machine to figure it out. And they will increasingly start providing feedback on why you should solve certain problems at all. Like you might go to a machine with like, oh, I'm trying to build this pump with these specifications, or I'm trying to build this CRUD app, and maybe it will dialogically interact with you. Oh, Varun, why are you actually trying to do it? And it will help you think clearly. And then once you've agreed on the specification that you've co-created with it, it'll be like, okay, Varun, should I just start creating this code base that does all the things? And you're like, yeah, go for it. And it starts creating sub problems and starts figuring it out. This is not science fiction. I mean, you can already do this. This is what vibe coding kind of is, right? If you pay $20 for Replit, you can already kind of start doing this, right? So eventually what will happen is that knowledge, broadly speaking, you can think of it as a pyramid, right? There's raw sensory data. From data, you create information. From information, you create knowledge. From knowledge, you create wisdom. Everything below the layer of wisdom in the next few years, I suspect, will increasingly become commoditized. And each different domain will have different levels of nines of reliability that you will be able to do this in, but it will largely just start becoming more commoditized. And that's kind of what we're seeing today. And I think if you want to create value, the thing that will create increasingly differentiated outcomes is the proactive cultivation of agency of wisdom, of thinking clearly, of working with disconfirming information, of working through your own personal biases and baggages, of kind of relating to the world in a much clearer way. I think if you take anything away from this talk, this is probably the most important slide. So if anyone has any questions, now is a good time. So yes and no, right? So yes and no. I think formal logic is incredibly important. But here's what I mean by thinking clearly, right? Okay, so let me give you a concrete example, right? An anecdote actually from this room from maybe 15 years ago. I was supposed to do some homework for Mac 2040. There was an assignment due. I was supposed to do it on Friday. I believe it was a Tuesday afternoon that we had tutorials, right? I knew the assignment would take like 2 days to do it. I kind of didn't want to do it, right? And like it wasn't the most interesting assignment. It was actually pretty boring. Right? It was a very uninspired assignment. Everyone collectively was sort of phoning it in, right? And there I was, with my friend who's not here. If you know Jason, maybe you'll know who I'm talking about. With a couple of friends, and I had a choice after that tutorial ended. I could go and work on the assignment, or I could go to Broadway with my friends and eat a kebab and maybe go to the pub afterwards, right? Now, what I chose to do in that moment is do as I say, not as I do, which is I decided to go hang out with my friends, go to the pub or whatever. And then 12 hours before the assignment was due, I pretty much just did like a mad scramble to get the assignment over the line. And because I kind of roughly knew my way through it, I kind of like bumbled my way through the assignment. And there are entire units I've gotten a high distinction for that for the life of me, I can't remember anymore. And like I just kind of like whizzed my way through it, and that was that, right? Is that relatable to anyone here? Don't be shy. No, not at all. All right. So and so this is what I mean by thinking clearly, right? Which is that the formal, like the above the neck sort of thinking would have extorted Varun, like, go and do this assignment. You're gonna have a really bad time. If I'd had a conversation with a logician, they would have sat me down and given me a very clear, maybe Tim would have come to the pub with us, but like he would have also simultaneously told us to do the assignment and like do the thing, but they would have given us a logical series of conclusions. Right.
So but you do remember going to the pub, and you probably had a good time.
I had a great time.
The argument could be made that it's actually not that important to spend any time on the homework.
For sure. So this is what I'm saying, right? Like there is more to rationality than logic, right? I really like the etymology of the word rationality, ratioanality, which is the proper proportioning of your cognitive faculties, and is extremely context dependent. And a lot of being rational is actually below the neck. It involves processing and relating to emotions skillfully. It involves relating to motivation skillfully. It involves having a like intelligent way in which you relate to yourself and others. And there's more to wisdom and agency than just doing the thing in front of you. And there's more to logic, there's more to rationality than that. Yeah.
Logic, but it's just not like you haven't put all the variables.
Right, or you can think about it, well, like, so say I go to the supermarket, right? There are choices I routinely make that are extremely illogical but deeply rational, right? Like, I know, for example, that say I'm having a bad day after work, right? I'm having a bad day after work. I know I need to deal with some emotionally difficult thing. I know that I can self-soothe by eating a cookie. It is probably not the healthiest way to self-soothe, so I can do the hard thing. There are probably worse vices I can have than sugar to self-soothe before I can do the hard thing. But you know what? It might not be logical, strictly speaking, to eat the cookie and self-soothe so I can like do the hard, emotionally hard thing. But it might be rational in some sense if the greater goal is to do the emotionally hard thing. So I just eat the fucking cookie, I like self-soothe, and then get the hard thing done, which makes everyone's lives like collectively better in that context. There's nothing rational about the fact that my body just seems to like chocolate chip cookies with a specific type of sprinkle on them. There's like no, sorry, logical. There's nothing logical about that. But it is a deeply rational thing for me to conclude, I kind of need to do the thing. I need to figure out how to emotionally get myself to do the thing. I've convinced myself to do the thing. Right. Right. And so this is kind of what I mean about the proactive cultivation of agency and wisdom is what I'm describing. It is extremely cross-domain. These sorts of dynamics emerge when you're deciding whether to do your homework on time or whether you should go hang out in the pub with your friends, whether you should take the job that scares you, whether you should, the way you should relate to yourself or other people. When your boss asks you to do a problem, do you mindlessly just do the what and the how? Or do you have the presence of mind to sit there and relate to the emotions or affective motivations of your boss to understand what actually is it that is going to create value in this context that might be completely illogical, but it might be extraordinarily rational, right? And it might be illogical in that formal logic kind of sense, right? Maybe your boss just really likes, I don't know, shipping a specific feature. They just really care about it or whatever, right? It's like reality can be complex. And so I think what we're going to increasingly start to see is as the how becomes increasingly commodified year over year. This might not necessarily happen in the next 6 months or in the next 12 months. What I am speaking to is the shape of a curve, right? Over the next few years, the how will start to become increasingly commodified. The what will start getting challenged, and the most differentiated value you will be able to provide within a company's value chain is to have a greater and greater ability to rationally reason through the why we're doing things. Why does this work? Why are people buying this thing? Why is this research problem interesting? Why is this happening? Right? At a much, much deeper level, and delegating increasingly boring instrumental things to the machines themselves. Before we go on, is that cool for people? Do people get a sense for what I'm saying? I'm seeing some nods, I'm seeing some shakes. I see. Is that?
So why before, not the why afterwards, right?
What do you mean?
So it's not to do nothing to like you're mostly framing not like it's why you're solving that problem, not why did whatever solution came up with actually.
Right. I mean, that's not unimportant. The latter is not unimportant of why did the solution work.
Yeah.
But what I'm saying is what will have the most differentiated value, I think, is why is solving this problem actually valuable? Do I actually understand that well? It might well be the case that your job in an organization is not to worry about that, and that's fine. But in terms of your own career growth, either in industry or academia, I'm pretty convinced in terms of differentiated value in your lives and careers, that like delving into the why has always been a useful thing to do, right? Like cultivating wisdom and agency has always been a useful thing to do. But I'm saying that in a world where things will become increasingly flattened by LLMs and the layer of what and how, this will become increasingly differentially valuable to have the curiosity and the capacity to engage in that why.
Skills you're going to see. What I have to dispute out what you're saying
Right.
is this idea of humans as value. They talk about value.
Right.
And already across the time, I'm dubious about the amount of value that I produce, but I also very dubious about what
Sure.
society's journey.
Sure.
Society's got to move commodities.
Yes.
But the value of the individual
Yes.
within society
Yes.
is not a given.
Yes. I am not, let's be very clear here. I am not talking about anything even close to your irreducible value of as a human being or anything like that. Yeah. 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 Right. Right.
Now have to find work out about what he's
Right.
reading,
Right.
to be able to
Right.
handle more appeal
Right.
as a crucial skill.
Yes.
Upended. People are not necessarily missing value. They are contributing, they are part of it.
I think, yeah, so I mean, I think this is a very deep conversation. I think my point in making, so thank you, that's a really good point. I think my point in saying all of this, so just to be very clear, I certainly have my opinions on what Tim said, but the point here isn't after this call or talk or whatever, you will go and believe that Varun is the arbiter of what is valuable or not valuable in the world and how one should think about value. The point that I am making here is that, especially as computer science students, because I think you will be affected first before any of these other fields for various reasons that we can talk about, I think it is worth spending some time grappling with the question of what is the value I produce locally in my environment, broadly in my environment, whether that value is aesthetic even in some way versus something extraordinarily tangible like pulling potatoes or lettuce out of the ground, right? But to have that broader conversation with yourself about within the set and setting that I as an individual am in, what is actually valuable here? Who here has the purchasing power to have the most influence about what is valuable? What interests me as an individual and motivates me to create? And how can I slot into that overall value chain? So it's sort of like a yes and to what Tim is saying, right? Like I completely accept that, you know, I don't know why certain things are valuable, broadly speaking, in society versus other things, right? And there is a substantial normative aspect to it as well, right? And it's complex. But that's not what I'm saying. That's not really what I'm talking about either. I'm saying, like, within the context of the individual, you have a certain levers you can pull on the environment. The environment is giving you signals about what is valuable and what is not valuable. And in the classical engineering tradition or education, I'm making a few exaggerations here just to be very clear, the typical engineers I would work in the last 10 years, they were often trained to emphasize their value creation at the how. They join a company, they get told, build this software for this. You might elicit requirements from the product manager or whatever, giving you those requirements. But the how and the what would be largely upstream of you. And what I am saying is that in a world where increasingly this thing is being flattened, it will be valuable for you to take an active interest within the milieu that you are in, within the environment you are in, to ask yourself some pretty hard questions about why is this valuable. And like I said, the answers might not be logical. They might be irrational, but they might not be logical. So for example, why is, you know, LLMs exist why is primary, secondary, and tertiary education not radically different? There might be some logical reasons for it. There might also be very illogical reasons for it. But the rational reasons are it's a system with many humans, it's not obvious what the replacement is, there are trade-offs on either side. These are things that don't have clear ground truth where you can just start with some axioms and just work your way towards a clean chain of entanglement. It requires, it's not logical, it's rational, right? And it involves a level of understanding the human condition that I think will be extremely valuable for all people engaging in industry. Does that kind of tackle, or does that answer the question or tackle your comment, or is that?
Yeah, that's perfectly good.
I'm not saying value going down.
Your
What no, where differentiated value lies. Because you can, let's have a really concrete example, right, to what we're saying here. Let's imagine a world where this is kind of an unrealistic thought experiment because the world is not static in this way, right? But let's say right now, Claude Code, Gemini, ChatGPT, they're so good that pretty much any CRUD app that you could think of can just be, you could pay $20, $100, you could give it a nice enough specification and kind of like talks to you, and in like 20 minutes, it just spits it out, right? Let's say we live in that world, hypothetically, right? Now, in that world, if anyone with a credit card can do it, that means that if I make a credit app that, I don't know, makes memes or whatever it does, or it sells like, I don't know, electronic medical records management, whatever the software does, it means that the cost of reproduction of that is also extremely low, right? Where if I have it, then you can have it, and we can all. So we are engaging in value creation because we're building a thing that did not exist before, and maybe each of us will get competitors. But because in this marketplace, we are not differentiated, we are actually not creating substantial choice in the market. What's going to happen is that we're going to start racing to the bottom in what we can charge for those services, right? And again, this is a very simplified, simplistic system with whatever. And so specifically what I am talking about, I am not talking about the fact that people will be unable to create value. People can create value just by breathing, right? I'm talking about differentiated value that continues creating profitable outcomes for you, however you define that, right? And right now, the way, you know, engineers differentiate from non-engineers is just by having the ability to do engineering, right? And it is an activity of extremely high leverage, and it allows you to like collect differentiated returns. It collects high wages or whatever. But in the world where everyone can do that because they have undifferentiated access to this API on tap, what does that mean for your differentiation if you want to maximize the value you can create within your local milieu? And also, I should clarify, I'm not saying this isn't a normative prescriptive thing. I'm not saying you ought to create the maximum value and contort yourself in various ways. That's not what I'm saying here. I am just talking about making a bunch of predictions about cause and effect relationships, right? Not, you know, trying to tell you what you should do with your lives. I'm just trying to tell you this is what I see happening in the market right now, and take a more active role in shaping your lives and thinking about how you think you fit to that, but also whether you think I'm full of shit or not. My invitation to you is to actually like think critically about what I'm saying here and reflect on it about whether you think it's actually like legitimate or not, right? Yeah.
How do you think it differentiate that?
Yeah, so I think this is where Tim was alluding to this, right? Is like there are many schools of philosophy that have attempted to grapple with this question for millennia. You could argue every religion is a millennia long conversation on what it means to be a good person and what it means to be wise. I think within the current secular milieu that we're in, there is a place for therapy to help us deal with our cognitive shadows and to become more well-regulated people so we can more skillfully attend to the world in front of us? The short answer is I don't know. But what I do suspect is that my doorway to doing this will not be the same as your doorway, and you will have to make it a personal, proactive quest. Just do science over your life. Just ask yourself, oh, am I a wiser person today than yesterday? I'm going to try doing a bunch of things to make myself wiser. Is this actually working? And yeah, maybe read some philosophy books, chat to Tim or anyone else about that. There's a bunch of cool philosophers at UWA. Read some books, do some stuff. There's no real any prescriptive answer with a framework that I could give you would immediately be not a good answer, because this is not a thing that you can create a one size fits all solution for, right? And so the invitation here is to, yeah, just grapple with this. Ask yourself these questions. Become curious about why you do what you do. Why are you curious about a certain subject versus another subject? Why do certain people buy certain things versus other things? Why do you find beauty in certain things versus other things? And most alpha, I think, in the market will increasingly come from the extent to which you understand your own human condition and the extent to which you understand the human condition broadly, and your ability to work with that information to be effective in the environments that you're in. So that's the short answer. I don't, a long answer, or a short, long answer is I don't know, but everyone will have to figure out their own doorway for themselves. And that is, I think, what will increasingly be required of us if we want to create differentiated value. And again, like, I think this is also why the economics of software, I suspect, will increasingly resemble the power law economics of the music industry, where Taylor Swift can change hotel prices in every hotel she goes to. There is a healthy middle, like, Tame Impala and the Black Keys are still big. I don't know if I'm dating myself with these bands a little bit. Okay. And they have a niche construction where, they can sell at concerts or whatever, but they're not as big as Taylor Swift. And then there's an extremely long tail of artists that are basically like starving, right? Because they haven't, for like, the economics are pretty sparse, right? And so my suspicion is that software will increasingly become this sort of extremely long-tailed ecosystem where it will be very like Pareto type dynamics, where extremely differentiated products can niche construct and generate substantial market value, and everything else that's a commodity will race to the bottom on the offerings that they're providing, right? And so as a graduate, like, well, where is the source of this differentiation? Well, it comes from you, right? It comes from how clearly you can think. And that's just not just like at the level of logical thought, which is good and important, but being wiser, dealing with your own cognition, your agency, your foibles, all of that stuff, becoming a better person holistically. There's more stuff I wanted to say, so I won't belabor the point unless there are more questions later. So this kind of touches on something we talked about pragmatically. What does this mean? I think what this means, and again, this is just my opinion, right? I think that society will increasingly rebase onto LLMs the way society has rebased onto the internet, right? Pretty much every business now is on the internet. I think pretty much right now you have this category of companies called AI startups, right? Or AI wrappers or whatever. In 5-ish years, I mean, it's already becoming kind of the case, but not really. In 5 years, I think it'll be increasingly banal to say that you are an AI company of some sort, like I'm an AI electronic medical records company, or I'm an AI like payment processor or whatever. It'll be as banal as saying, today, if you said I'm an internet startup, you just chuckle and go, what are you talking about? Of course you're an internet startup. Of course you use the internet, right? Like, I think this stuff will become so accessible and untapped that it'll just seem really banal to say, like, oh yeah, I'm an AI, whatever. And so the tangible thing is that in the past, like, industry and academia, especially for deep learning, used to be this really distinct thing. So when I was here at UWA, sitting in these sorts of rooms, right, I worked on this problem called core reference resolution, actually with Wei, who's sitting here today, and we got a thing published. And that, that entire body of work, like, not just my paper or the paper we published, but that entire academic discipline can now be solved with a single prompt from the worst model available today with a credit card And in the past, if you wanted to write, so co-reference resolution, for those that are not familiar, is you want to solve the problem. Bob went to the beach. He loved it there. How do you get the computer to figure out that Bob and he are talking about the same thing, or there and the beach are talking about the same thing? So it understands how to resolve these things, right? This used to be an entire academic discipline. There were hundreds of PhDs minted on this one discipline. I did my honors thesis on this discipline. There are dozens of benchmarks on this discipline. People have spent lives working on this problem. This problem can now be solved. People used to train ensembles of models. They used to do all kinds of fancy stuff. This entire problem. Right. 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 And now, if you look at this problem you can solve almost across domains, across like data sets that were outside of academia with a single prompt. And moreover, the prompt will do something existing approaches couldn't do, where you might have had this gigantic code base to like run these classifiers, turn them into the structured formats, so some downstream pipeline could use them. That prompt will now spit out JSON that some JSON parser will just, parse, and you can do useful things in it. And you can do way more sophisticated stuff, like you can do the co-reference resolution, and then you can give it more instructions on how it resolves the reference and do all kinds of things. That's just a prompt now. And so the other thing that's happened is that in the past, like what would happen is that research was this kind of ivory towered thing in deep learning, where because the models were still kind of brittle and it was difficult to make money off of them, there was actually a very tenuous relationship, even in industrial labs, between kind of getting an improved, compared to today, getting an improved performance on ImageNet or something like that, and actually shipping this to production and making money off of it, right? But what happened once LLMs become popular is that these two worlds like crash collided onto each other, where it meant that previously in the past, maybe only academics would care about improving the performance of some co-reference resolution task. But now suddenly some companies' P&L, because you could ship this intelligence on tap, suddenly some company, like the P&L was being impacted by the quality of the model. So what historically used to be called research, suddenly in 2 years became merely applied AI. And there's suddenly like no need for academia to work on vast entire fields that it used to work on before, because it's now become the province of companies trying to make money off of it, for whom it is rational to spend money to improve their models on those tasks, or create a market demand for the frontier labs to improve those specific use cases. And so you now have this world where you see a lot of papers where the paper is basically, we have this novel task that we thought would be hard for the model to do. The task can often, I've seen so many papers that are actually adjacent to some engineering task, actually, right? It's like a thing a company might care about or something. Some academic picks up a data set, works with a company, they prompt a model, they create an eval, and they do it. They're not really doing research anymore. They just, you're just, the company is really just arbitraging the engineering required because maybe they can't hire those people themselves. But there's no real novelty left there anymore. It's like, yeah, if you prompt tune the models enough and you have a good enough eval, then yeah, you can hill climb the thing. But if you're not training the models yourself, or if you're not answering really interesting questions about human cognition or how reasoning works, right? Is that really academically interesting? I mean, I don't know. I mean, it's something worth thinking about, right? Like, which isn't to say there's nothing worth doing in academia. I'm going to talk about that in a second. But it's had this very real dynamic where I don't know how much of academia has realized that large swaths of what used to be considered research just isn't research anymore. It's just prompts. And his company is trying to make money off of those prompts and create market demands for the frontier labs. And so I think it then behooves academia to do more interesting things, and we can talk about what those might be. But that's also something to kind of keep in mind if you're an academic and you want high impact publications. Is I suspect journals in academia increasingly will start correcting for this. I'm a bit out of touch with what the latest NeurIPS bar is, but that's just something to keep in mind. And so, yeah. 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 Yeah, I think it's a bit of all of the above. So, I think pre-training had a big impact on it. So even in the past, um, so let's forget about LLMs for a second, right? Imagine we go back to like the good old days of 2017 or something like that, right? And let's say you have a task for which you have relatively little training data. Could be medical images. It could be. I remember there was some farmer that trained a cucumber classifier, like is the cucumber good or is the cucumber bad or whatever. Yeah, just sort of rando tasks, right? For which there might not be a lot of data, and the task itself was extremely hard for whatever reason. What people figured out is that you could do this thing called pre-training, where you could take some other task like ImageNet, which had a substantial amount of labels in it. Like ImageNet, I can't even remember. It's like many tens of thousands of classes worth of data in it. And what you could do is you did what's called pre-training, where you train the classifier on ImageNet, and then instead of initializing your, let's say, pickle classifier or mammography classifier or whatever from a random set of parameters, you would start from your ImageNet trained model. And what would happen is because you trained the model on a visual perception task similar to mammography or pickle sorting or whatever, the model would learn representations of the data that it would learn good representations for discriminating between different classes of natural perceptual data. And that would mean that when you started post training from that model on your domain for which you have very few examples, you would need relatively few examples to actually get good performance because you wouldn't have to waste training examples from your scarce domain to teach the model good representations of kind of perceptual imagery or something like that. And then in the case of language, I think what happened is that people figured out how to do pre-training on language, right? And so this is the GPT-1, GPT-2, GPT-3 papers, the BERT paper. Like there's a whole bunch of papers that came out where they did various sorts of pre-training, where they just took all of Wikipedia or the entire like crawl of the internet or something like this, like massive, massive amounts of tokens of text, and then they just fit a model to predict the next token given a fixed context window. And what happens is that if you do pre-training on a task like this, on all sorts of natural language tasks, your model, you're actually doing an inherently extremely multitask problem in predicting the next token really, really well, which causes the transformer to learn good representations of the distribution of language itself, or the distribution of the sorts of things that then when you post-train to do co-reference resolution, it already knows, quote unquote, or already has good representations from that task. Because there's actually a really nice talk by, I believe, Jason Wei or Hyung Won. I can, if you guys remind me, I can send you a link where they kind of talk about this, where I think by scaling pre-training higher and higher and higher, you just form really good representations of the world writ large, right? And so what you end up getting is that the LLM becomes a sort of world model that contains sort of like, yeah, exactly. And then so when you get a task for which you have relatively few examples, you don't have to waste as much time training the transformer to learn good representations of it. It already, the parameters, the parameter vector is already in roughly the right space. You just need a few updates to shunt it into the space you need to do coreference or whatever really well. Yeah. Right. Sure. There's a lot of images on the internet. There's a lot of images on the internet.
You probably want to be able to share like a multi-mode, not just a single modality as an image model. So you have the cross modality, those is have association with text, so it can learn the representation in the invading spaces.
So, and just to be clear, this is not pre-training is not a solved problem by any means, right? It's just my mental model. We were talking about it at lunch. Is like someone figured out a way to build a better sort of engine that seems to be able to process fuel way better than before. So it goes brr way faster and way further and has way more capabilities. And there are still open problems in pre-training or scaling or whatever. But it just seems like this way of doing things is much more data. I don't want to say data efficient, but it's like much easier to scale to a plethora of tasks than learning each task individually. And you kind of saw that with HUD back in the day or deep learning models back in the day, is that generally if you train a model on a whole bunch of disparate but related tasks, it would be able to share representations between the tasks, and therefore the aggregate performance across the tasks would be better than if you had a very small amount of examples for each one of those tasks. You trained in models like separately for each task. So you can imagine this as a sort of massive scale up of that whole process. Yeah. That's right. Yeah. That's right. Well, I mean, like things die and things rebrand. I mean, I think this is kind of like what I was saying. I think I'll get to this slide next. I mean, I think what's happening again is because industry and academia have kind of collided in this way when it comes to scaling up models. There is substantial work, I think, happening in all these things, but personally, for me, the most exciting work is happening inside of industrial labs in terms of scaling things up. And I think that's just what it is now. It's sort of like for many years, people were trying to, academia or researchers were trying to invent an engine that could be useful for all kinds of domains. The transformer got invented. People did stuff to make the transformer like almost good enough. And then industry did what it is supposed to do, is it translated that and scaled it up massively. And now we have LLMs. And so yeah, so coming back to this, like there are implications for industry as well, where in the past the way we used to train engineers was to work with deterministic software, which is like most senior engineers, if you gave them the specification for a CRUD app, they'd be able to pretty confidently say whether the CRUD app can or can't be implemented. It's generally, databases or like implementing if-else state, like generally software in the way we've historically thought about it is very deterministic. There's a lot of research that has come from logic, programming languages theory, etc., to generate various forms of formal certainty of what programs will and won't do. And we've, as a culture, built a lot of processes for dealing with that and shipping software. But I think as LLMs become more integrated into industry, a big thing that's going to change is that LLMs are just not deterministic in the way classical software used to be. They're inherently stochastic in nature. Even at inference time, they won't produce the same thing again and again, assuming you sample in a certain way. And so it means that cultures have to shift from formal certainty to reasoning through statistical confidence. Like in the past, let's say you wanted to make some sort of business to business, like B2B, business to business software as a service application where you sell at some subscription, maybe, I don't know, you're making like a booking service for hairstylists or whatever you're doing, right? At this point, we kind of know that, yeah, it's possible to make a database and hook it up to a web app to make the thing work. If you can't figure it out, it's usually your fault, not the software's fault, like it does what you tell it to do. And if you were building a new product for something like that, most of the risk with something like that would be in the market risk. It would be like, will someone actually pay for this, right? But the issue now is as we transition from software that is amenable to formal certainty to software that at best only provides various forms of statistical confidence, you have to, when you're developing new products, you have to simultaneously take on not just market risk, but product risk. Well, sorry, technological risk, which is like, will it actually ever be possible to get the LLM, say you're making some recommendation system for hairstylists or whatever, I don't know. Will you actually get the recommendations to be good enough that someone will pay money for it, right? You fundamentally don't know until you've tried. And so every product development problem when you're dealing with stochastic software becomes a research problem in its own right, in some sense. And that necessarily changes the way businesses, the cultural processes that businesses will need to have in dealing with this risk. It means, and at the same time, you'll have Cursor and these other tools which will allow you to substantially reduce your headcount, focus on your go-to-market, and reach new levels of automation to quickly extract that first dollar from your customer, right? And on the flip side, in academia, kind of like what we were talking about before, I think industrial labs will probably lead in scaling these models up. And I think a lot of methods-based research, like if you're designing a new optimizer, if you're designing a new architecture, you're designing, inference time scaling has been kind of the rage. If you're designing a new algorithm to do RL or whatever, I'm not saying this has no value, but I think you will have to calibrate, you will have to be more thoughtful if you want to do this in academia in terms of your strategy with how you relate to that research, right? When academia and industry are pretty divorced, good ideas were good ideas, there were benchmarks, you climbed those benchmarks. But because there's so much industrial heft behind what truly works, the things these days from academia off the sort of methods-based research, it seems the things that gets the most attention if you want to translate things are things that you can show, yeah, if you scale up compute or if you scale up data in some way, the gains you get with your new method on this benchmark, they don't get washed away with more scale. It turns out this is actually a more efficient way of, like a more sample efficient way of training, not just at, a 100M model, but also a 500M model or a 1B model or whatever. And it means that a lot of research problems in NLP, vision, speech, etc., have actually just become industrial problems because now it's suddenly possible to just write a prompt that does mostly what you need, build an eval to capture that specific market-driven thing, and then go to a frontier lab with a bag of money or a willingness to buy and be like, oh yeah, if you like hill climb on this eval, we'll both make this much money because I'll send you this much business in inferences, right? And so I think academia, I'm not saying don't, I want to be very, very clear. I'm not saying this sort of methods-based research or this sort of research in classical academic problems like perception, et cetera, have no value. That is not what I'm saying. I am saying that if you want to be competitive in these things and publish high impact novel work that gets published in all the right places, et cetera, the bar will just become increasingly higher and higher because largely industry will do its own thing, right? Like these are becoming industrial problems and they got scaled up by the labs. And so I think this is going to lead to a sort of 10x level of differentiation, not just in industry, but in academia as well, and the sorts of problems that get people try to carve a niche around things, for example, the models just can't do, or the things that, are really difficult to evaluate for, or the things that are really hard from like a human sense. And I think right now, this is again my opinion, the most alpha for really small labs or labs without substantial compute, right? If you don't have like dozens of H100 clusters just like lying around, my suspicion is to shift research to focus on various sorts of cognition. And this is like an intermediate slide. I didn't really know where to put this, but as I suspect as you do all this and as you metabolize these new insights, I think if you want to stay relevant, I think it will be important to create an instinct to use LLMs for pretty much everything. I don't care what your advisor says. I don't care what your like lecturer says. You should talk to them about it. This is my personal opinion. I don't have skin in the game in your relationship with them, so I can say this freely. This is how I am choosing to relate to this technology. I think that it is worth figuring out how to use LLMs for literally everything you do in your workflow, no matter where you are, and to do this wisely. So if, for example, you go into one of Tim Alway's classes and they've given you an assignment and you just mindlessly prompt Claude to like ace the assignment, you're probably ultimately going to be the loser. You're just fucking yourself over, right? But if instead you go into that assignment, you convince yourself that, yeah, I could actually do this myself. And I would actually argue you should do each assignment twice, once without the LLM and once with the LLM, once to convince yourself that you can do it without it, and the second time to show yourself just how much more accelerated you could be to use it with the LLM. I think that is a much more, preferably in that order, right? I think that, yeah, that's right. Oh, really? To your class? Yeah. I think that is a much more skillful way of doing it, where I think fundamentally what you want to do is you don't want to relinquish your agency, but you want to substantially 10x your capability. And because these models will become better and better, it will become easier and easier to do the assignment the second time and convince yourself, oh shit, I can do this really fast, right? And so I would really recommend, and this comes back to like wisdom, right? Yeah, you could just cheat on your assignments. It's really hard to catch it. You'll probably get away with it. Probably cheating yourself. That's probably an example of foolishness, right? Or you could use these tools skillfully to figure out how to actually maintain control over the system and understand what is actually being required of you. And then once you've convinced yourself you can do that, just accelerate everything balls to the walls with the LLM. Almost make a challenge to yourself, as if it took you like 2 weeks to do some assignment. Make a race with yourself and how many hours can I knock off this entire assignment just by prompting my way to victory, right? Like I think that's a useful pedagogical exercise, right? For pretty much everything you do, whether it is, solving differential equations, solving free body problems, solving like CS assignments. First convince yourself that you can read, and then convince yourself that you can wield this thing with confidence and agency to substantially accelerate the way that you could do it, right? And use it for just everything. Use it for like doing literature reviews, use it for editing prose. And what you'll also find as you do this, as the models are actually quite terrible for a lot of tasks. So you'll find the spectrum of there are some tasks where the models are just irredeemably terrible right now. There are some tasks where if you prompt them enough or prompt them right, the models will let you do the same thing. And there are some tasks where you can just first try it, reads your mind, and you can smash it out. It's also worth having a sort of theory of mind and intuition when you spot a new problem of where that problem is going to slot into. And the easiest way to do that is just by using tools. And this comes back to what I was saying, and it sounds like way is echoed to a class. If you do this sort of mindlessly, you're just kind of shorting yourself or screwing yourself because you're losing control, right? You're just like pushing buttons on a keyboard and like random stuff is happening and you're not actually digging to the why, right? Like, why are we doing this? Why is this working? What was it about my prompting that like made me effective, right? And give yourself like more and more cognitive capacity in that way to solve problems that you couldn't before. Just to clarify again, Do not use LLMs to cheat. I am not saying this because I care. I don't really care about your accreditation. I'm not your lecturer. I have no skin in the game. I am just, trying to pay it forward by telling you you're going to screw yourself if you do that. But at the same time, if you just don't use these tools, you are also effectively going back to like 2000 when search engines have come out and people are just whizzing away learning new things that they couldn't have. And you're like, nah, this is a fad, or nah, I haven't gotten around to it. So there's two extremes. Don't fall on either one, right? Yeah.
Do you have any specific recommendations for
No.
code generation? Do you have any experience with
Yes. They're each good for different things, and it is your job. So this comes back to the why, right? It is your job to figure out which tool is appropriate for which job, and it is your job to make that skillful determination of, given your finite time, how are you going to choose to prioritize that time so that you can effectively increase your agency as an individual. And yes, there are a lot of tools. You're not going to learn some of them. That's fine. I could give you some recommendations. I mean, Cursor is great. Dev and Replit are great. Perplexity is great. But me giving the recommendation is self-defeating because the point I am trying to make is that you should take ownership over your agency in working with these tools to create recipes for yourself to substantially increase your agency in the sort of context that you routinely find yourself in, right? Does that make sense to people? All right. Yeah. 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 Right.
And yeah, absolutely. LLMs make it. But what I think we do a lot, or what we try to do,
Sure.
you need to learn.
Sure. Sure.
Use an LLM after that.
Yep.
But it's awesome, right?
Sure.
You make me do it.
Sure.
Because you pretend to be doing it.
Sure.
Learning is what is about that.
Right. Right.
And the LLM
Right.
it's not necessarily
Right.
quite a program.
Right.
You get a solution, quite a program.
That's right. So I would yes and that. I would agree with you that the purpose of university is knowledge and learning. And this is precisely why I will say this again. Cheating, I'm not advocating cheating. What I'm advocating is doing every single assignment you do in uni twice. First, without the LLM, and second, with the LLM. And the second time that you do it, the reason by that point, you should have done it yourself already. Go get a high distinction or whatever they're calling it these days from whichever unit you're doing it. The second time you do it, what you're doing, who here has seen Code Golf? You know what that is? Is that still a thing? It's like a programming competition where you try to like make the smallest program as fast as possible or something like that. The reason you're doing it the second time is you're learning how to use the LLM. You're learning how to use the LLM to be effective. The way you're learning how to do the actual thing is the first time you're actually going to do the assignment. The second time you're going to do the assignment is you're going to see how fast you can do the assignment with the LLM, with the foreknowledge, if you kind of know how to do it. And yeah, maybe you might chuckle, maybe many people won't do this. I'm not really saying this for the benefit of those people. I am saying this for the benefit of people who do want to substantially increase their agency capacity. For you, I am telling you, do everything twice. And the second time you do it with an LLM. And as the models get better over your 4-year degree or 3-year degree, you will get a better sense of what they're good at, what they're bad at. And to the point of learning, I would also, this is why I'm saying, do lit review with the deep learning research tools, create your personal evals. I'm saying, like, say you know, like, you're going to do Math 2040. I don't know why I'm picking on this unit. It was actually a great unit. Say you're doing that unit of physical electronics or whatever. What I would suggest doing is, before you ever walk into the lecture, try to look at the course outline and ask a bunch of questions that you might have, and proactively speedrun, try to learn as much as you can possibly can. Like, even the act of learning, you should figure out, how can I increase the rate at which I can metabolize and ingest information in a credible way faster. And that's why I'm saying, like, yeah, if you just like take an assignment, copy and paste a PDF and have the model spit it out, yeah, it'll make your lectures look good because the mean for that class will go up and you might get your mark, but that's ultimately self-defeating. What I'm saying is, take everything that you are learning from university. The point of university is to learn. The internet is an incredible resource to learn. LLMs are an even better resource to learn. And ultimately, what I learned from university was a set of skills, either because of or despite of my university education. And what I am kind of inviting folks to do is figure out how you can reproduce the act of learning while you're at university itself using the LLM. And given that there are already university materials, you already have ground truth for a bunch of problems or whatever, see if you can replace the act of learning things. Or if you're like a super motivated person, like let's say you want to learn music or insert, like, there used to be this thing called overloading units when I was in uni. I'm not saying overload a unit, just randomly, if you're doing 4 units a semester or whatever, pick a rando unit that you're going to be like, I'm going to spend an hour a week learning this unit. You can usually find the course materials for that unit online, and try to see if you can eliminate the entire human delivery pedagogy from the equation and use the LLM and the course materials to just speedrun your way through the unit using the assignments as ground truth to see if you can entirely learn something new really, really quickly with the LLM as a tool, to see to what extent you are bullshitting yourself about the extent to which you are learning from the LLM, right? Because like this entire model of pedagogy where there's a person standing in front and there's people sitting, I think that's all going to go away soon. Like, I think it's mostly like, no, I mean, I think everyone is going to face kind of evolution, right? But I think it's all going to change. Like, you have a personalized learning assistant that can tailor itself bespoke for you and your personal cognition. And your agency is going to be a function of your ability to wield this, right, in an adaptive way. So right, 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 right. Go at your own pace, look for stuff online. Right. Right. And then you could imagine the lecturers are now there to provide motivation, solve problems. So like something so I have a few friends who are doing startups. In the past, I was telling folks at lunch this. In the past, the way interviewing used to work is you'd go to a whiteboard or whatever, you'd solve a bunch of technical coding problems. Maybe some of you have been through this process already, but that's now increasingly becoming self-defeating because you can just get a model to solve these like ICPC style problems or these algorithm problems, right? So something some friends are doing is you do an initial phone screen where someone like you just check quickly this is a person like coded all, right? Some people will like lie, right? And then you get this person to come in person, you lock them in a room for 2 hours, you give them a specification of what you can build. You tell them, yeah, if you have questions, ping me, or we can sit co-work next to each other. And the interview problem over those 2 hours, the specification is so hard that you can only succeed at it if you use an LLM effectively. And that's maybe a more effective way of interviewing people because it's seeing to what extent can you actually like solve problems with an LLM. And what I was describing here of learning, speed running through a course and learning it given the ground truth of the assignment answers and whatever, is kind of like a more academic version of that, right? Like put your agency in your own hands and kind of yes, 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 yes. That's right. So, but that's kind of what I'm saying though, is in a model where there's one person talking and there's 10 people listening, you necessarily end up with some sort of mean regression where you can only really go as fast as the lowest common denominator or the median or something like that. And so the point of this provocation that I'm putting out there is it can be extremely important for you as a person to understand what your own limits are, right? To understand what your own natural limits of cognition are, learn practices of studying more effectively. See, I've never really been, people talk about work smarter, not harder. I prefer to think of it as how much leverage do you have over your environment, right? Like it's like just be more effective. That's all that really matters, right? Or like if you're thinking about it in that dichotomy, right? There's nothing more noble about spending 8 hours doing this thing if you can do it in like half an hour and you can still get the same cognitive benefits, right? So yeah, just use LLMs for everything. Be smart about it. Don't cheat yourself because ultimately it's just you that'll lose out. And there's another thing that I've been thinking a lot about. Like, I think, I don't know what this is going to get called. I think there's going to be a new field that's going to emerge soon. That's going to be like a mix of cognitive science, software, and machine learning. I don't know that any academic community has a consensus on it. I've been calling it cognitive engineering. And it's this idea of using LLMs to substantially cognitive enhance human agency and wisdom at the rate at which humans can be effective. And there's all kinds of like open questions, right? I think AI therapists are a horrible idea, just like a truly, truly awful idea for so many reasons. But there might be various reasons why, like certain forms of them could be adaptive. You know, personalizing models is still pretty hard. By the way, for the folks taking photos, I'll send a link later. You don't have to do that. It's fine. Just like if Pascal or someone reminds me, I'll send a link. But like, how can we humans better personalize these systems to themselves? Or we were talking about like using LLMs to like solve problems. Like there's all kinds of interesting HCI style problems as well, where like, what if you had 3 arms in an experiment where the first arm is just the model, one arm is just the human, and the other arm is like the human and model combo, and you look at like the trajectories of creativity. There are lots of existing psychometric kind of definitions on word creativity tasks or whatever. How can you measure, benchmark, and assess the extent to which you can expand your cognitive abilities with an LLM, right? Like we're tool wielding primates. There's a term that I believe Professor John Viveki at the University of Toronto has coined that I love called psychotechnology, right? Is the idea of a technology for the mind. Literacy, the act of being literate, is such a psychotechnology. How can you use these LLMs to substantially improve, like increase the effectiveness of your psychology? Like say you have a problem which doesn't have a clear answer and you're grappling through the why aspect of the problem. Can you brainstorm them? There's a lot of possibilities here if you're fishing for like an honest project or something. I think there's some really interesting stuff here that you could probably work on and you could create evals for using just existing LLM APIs. And that's it. I don't know if we can go to Q&A. I know I shared a lot of stuff at you, but I thought that would be interesting for the remaining time. I didn't anticipate. Thank you for all the questions. I guess we have 20 minutes left, but I'm happy to like chat for a bit longer after that, depending on what people want. And so yeah, thank you for listening. Yeah. So any questions?
Not build one day. For 2022, nothing like this happens. Everyone still have their own little area
Yeah.
to do their value.
Yeah.
Differential value. 2022, everything changed.
Yeah.
Before that, when you kind of deep mind things, what's the thing inside of it, like more people know this is the right.
Oh, so you're asking like before 2022, how did people know in
Yeah,
DeepMind that this was worth investing in?
Yeah,
Um, I don't know that. I don't know that. I'm not going to speak for all of DeepMind. I'm just going to speak for myself. I didn't know that even I knew that this was going to be as big as it was. So I started working on LLMs maybe a year or so before ChatGPT came out. It was for kind of code completion tasks and kind of code generation tasks. I don't know that even I appreciated how profound this was going to be, but I think on some level, like you had these evals and the performance of these models on these evals just like kept going up. And it seemed like if you kept scaling, the evals would keep getting better. And so it led, at least to me, this natural question of, damn, what is the natural limit for this? I don't know. And so I don't know that. I think there were certainly some people like maybe Noam Shazir or whoever, like, you know, a bunch of folks, Ilyas Sutskever, a bunch of folks at OpenAI who had the foresight to see like, yeah, this is going to be a big deal. But I'm not gonna speak for anyone else at DeepMind, but I certainly didn't have that foresight until I actually started working on this problem and saw, wow, these models are improving really, really quickly, you know, and it just so happened that because I was working on it before ChatGPT got launched, and I certainly, when ChatGPT did get launched, I personally certainly did not anticipate how big it would become because just a few months prior, Microsoft had launched a model called Sydney or something, and it wasn't very good, right? It said some pretty insane things and it got rolled back. And I don't know, history is weird like that, you know? Maybe it was just a specific threshold at which the public, broadly speaking, thought it was cool. No, I mean, I think I don't know, I think these things are pretty complex, and I think backfoot is kind of, it's easy to say that in retrospect, and I think the set of conditions that leads to a certain thing getting launched is also kind of complex. But I think there are certainly a lot of believers in a lot of different places. And I mean, if you go to Gemini now, Gemini 2.5 Pro is actually like a pretty strong model. And I think it's at the top of the LNSys benchmark or something. So I don't know. I think history is complicated, right? And I mean, I'm not going to speak for Google or for my ex coworkers or anything like that, but just speaking for myself, I don't know that I had that kind of prophetic sense that this was going to be huge. But I think once I started working on the models itself, I think I kind of got it. And then I think the moment, you know, ChatGPT came out and, you know, people, you know, started working more on Gemini and stuff, I was pretty at least at this point, I'm extremely LLM pilled. Like, I think. I can't really talk about that.
Okay.
But happy to team.
I can't really talk about what I did at Google in that
Like-
level of detail. I think.
Okay, then what's about the opinion? Like, well, how much do you think that the data playing the roles in this kind of,
I mean,
like 150 or?
I think it's really hard to answer a question like that in a general way. I think taking a step back, like we published something called the Deep Learning Tuning Playbook, and I think that entire playbook is on hyperparameter tuning, right? But I think something I've seen in my career again and again is that yes, tuning the model is really important, and yes, getting the right architecture is really important, but having a really clean eval and having a large enough data set that's clean enough to work to fit a model to is actually extraordinarily important, you know. But it's very difficult kind of retrospectively to say like this thing was this important or that thing was that important unless you ground it in a specific use case in a model. And I can't really talk much about Gemini, I'm sorry.
So it's more like,
I think the data is, look, you build an intuition of what is important based on what you work on. And I think, in general, look, let me put it this way. In general, it's a good idea to have a good data set. In general, it's a good idea to tune your models correctly. I think this can be pretty problem dependent. How important was the data versus the model? And this is also why deep learning is sort of kind of alchemical, right? Which is like, you can kind of make an a priori estimate about how the constituent pieces of your training recipe are going to be ahead of time, but until you've actually like run the experiments, you don't know, you know. Yeah, I mean, I can talk to Cohen whenever. So if like anyone has any questions, I'm happy to chat. Okay. So I'm not really sure I understand the second question. Can you please if you feel comfortable, can you please unmute your mic? I'd be good to like understand the question a bit more.
I think what he means is more from doing the unsupervised learning nowadays is nothing.
Okay.
Reinforcement learning. Then take the students as the large language model. Can you also do the unsupervised learning? It's like what you two kind of debate here, like if there is no team and we and just put it in a classroom to get the learning device.
So when you say, I see. So when he says unsupervised learning, what he means is in the future, will you have a world where you just kind of put some kids in a classroom, give them access to a chatbot terminal, and tell them to learn, and then just have them learn? Is that? And he's asking, like, is that going to be the future of education? Is that? I mean, I don't know. Well, yeah. I mean, I don't know. I mean, you should ask someone who works in education. I mean, I have no idea, but I mean, I mean, Pascal, I mean, sorry, not you, the person who asked the question. I mean, this person might be interested in looking at Montessori education and learning a bit more about how those classrooms are structured and how, maybe I don't know that I'm even remotely qualified to answer a question like this. But I think what I will say is that from the perspective of an individual learning, or let me talk about myself, right? I generally just go to a chatbot before I go to a person if I want to learn something new. Like, why wouldn't I? And I still know like tons of people who know things, but I think, look, let me put it to you this way, right? So when I was actually, so maybe this is an interesting anecdote. When I was in UWA, I worked with a friend to make a nonprofit to help high school students get excited about STEM, the ones who had fallen through the cracks. Because especially in Australia, like we have, Hex. I don't know what it's called now, or maybe it's still called Hex. We have a lot of access to universities. We have a lot of great universities. There's a lot of opportunity here relative to other countries. And, me and my friend thought it was kind of a shame that there's a lot of people maybe who could go to university, have the skills, but for various reasons don't go. And we started doing things with the education system, and we quickly learned, not vilifying anyone or whatever, it's just that the system itself is extremely ossified, very slow moving, very slow to change, with an extremely large array of conflicting incentives, right? And so if the question is, do I think it will be technically possible for students to do this? Maybe, I don't know. Do I think this will actually happen? Well, I think this is also one of the reasons why I think just because we have substantially powerful models, I don't know that that necessarily means the GDP will grow by 50% year over year or something insane like that, because ultimately people are still a major limitation And there's more to learning than just like sticking someone in front of a screen and being like learn and like getting them to just like learn, right? It is social, it is affective, you need someone to provide guidance and mentorship. And you can imagine a world where there's a spectrum here, right? Where like more and more of that last mile could be delegated to a machine. But I think there's a reason you learn things beyond just making money. Maybe you do it because it's interesting or fun, or maybe you do it because your friends are doing it. Maybe you do it like there's reasons beyond just pure productivity. Um, but yeah, I'm not remotely. I don't know. That's my opinion, but
how would you go about like
oh man,
scientists in the context of
I don't know if I'm qualified to
well, no,
even.
yes.
Um,
Yeah,
yeah, I would say that almost my entire curriculum at UW, like assuming the way things are taught today as they were taught 10 to 15 years ago, I think almost all of it probably should change at every layer of abstraction. I think just very little of it makes sense to me. I think that I think that I think that what I think just the overall business model of a university just does not make sense to me in this new world, because I think the bargain has been the social contract has something like we'll take these really smart people who've done a lot of research, we'll call them professors, right? We'll give them the autonomy to do their research. To what extent that is actually practically true today, that's a separate conversation. And then what we'll do is we'll get all of these students to pay money, and what the students get is we will force these people who may or may not enjoy teaching to be in the same room because they're very smart, qualified people to teach these students who theoretically want to learn. And so at the same time, the university model satisfies the role of accreditation, like providing students the ability to find a job, learning to whatever extent that happens, and that requires a lot more causes than just the learning, paying for research or creating like an ecosystem from which new human knowledge, the torch of human knowledge can flourish, right? And then kind of teaching critical thinking. And I think once you get into this world where the marginal cost of distribution is zero, I think what of universities, especially in the world of Coursera, or especially during the pandemic, they decided that, oh, we can just make these courses online and we can just make recordings or some stuff like that. But that never really made much sense to me because the production value of these things was often extraordinarily low and extraordinarily poor. And people just kind of went through that funnel because there was no other game in town, so to speak. And I think for CS in general, for example, in New York, I know a bunch of boot camps where boot camps have a derogatory kind of reputation for them or not. But, people have iterated on that model a lot more. And, there are some boot camps that are actually extremely successful at in 4 months giving students the ability to learn with these tools from the internet and get placed in kind of good jobs in big tech companies in New York or the Bay Area. And so I think like the fundamental economics of university in general will probably come under tension because I just don't think the maths and the value provided just makes sense anymore. Like I think like if you're in high school, would you rather pay 10 grand and spend 4 months and get a job as an engineer, or would you pay like and go into hex debt or whatever for many tens of thousands of dollars to go to this institution? And you could argue there are intangible benefits you get from getting that university experience, but I think there'll probably just be more choice for stuff like this, especially for software where it's not really regulated in the same way as like electrical engineering and things like this. So I don't know.
you'll just be using like you'll write some code because the opportunity that'll just be folded into that.
Yeah, I don't know. Yeah, and I think the other thing is that computer science won't be the only field that will be changed by any of this, right? I think that tertiary education more broadly, and this is the thing, these are very slow moving systems, but I think that computer science is where the market attack will come from first because it's kind of unregulated and you don't have that same sort of thing to get a job. But I think like, yeah, I just don't think that the way tertiary education is delivered today just makes any sense to me whatsoever, especially for computer science. It just makes like no sense. I think like if I were in high school, yeah, I mean in Australia it's a bit easier, but if you're in America and you're accumulating this massive amount of debt, I don't know, man. Like I think the calculus is becoming very, very difficult, like maybe one reason you go to a university is so you can get like it's easier to get a visa, or like it's easier to do these other things, right? Like, or maybe you meet someone you end up marrying, maybe that's like a good motivation to be around a lot of like 18, 19-year-olds, I don't know. But that's not what we're talking about, right? Like, so I think, yeah, I think education writ large is just has a lot of question marks before it. Yeah. Yeah. Yep. 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 Yeah. Yep. 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 So, I mean, I don't have a short answer for these questions. Yeah, yeah, I've thought a lot about this. I don't have any short answers here. I think what I will say is that yes, the models can hallucinate, but the reason I think this is worth researching. So the first thing I will say is I don't have the answers. I don't know anyone does. I think that's what makes it an interesting problem for academia to think about it, because I think I don't know that I don't know how many other sectors of society there are that has both the technological sophistication and the quote unquote patience in terms of time to pull these threads responsibly and meaningfully. Certainly, probably not companies that are just trying to ship this stuff as fast as possible. So there's a bunch I can say about this. I'm actually not going to go there because we're almost out of time. I think what I will say though is that the sort of use cases I've described here, it's not hypothetical. Millions of people are using these models to do this today, and there might actually be, I actually think there are for some of these use cases, substantial psychological and societal risks around emotional dysregulation and stuff like this. And so I think that's also why I think in academia, what I've noticed happening is that each field like psychology, um, cognitive science, machine learning is nibbling off a bit of this problem, but I haven't actually seen a field yet that is the synthesis of all of these concerns. And it seems to be inevitable that such a field will emerge in academia just to grapple with these questions. And I don't know that anyone has clear answers to them. And I think so. So I think that, well, but that's why I think it's a good field for academia to wade into, because I don't think there is anyone who has enough authority to like conclusively answer these questions, right? Right. 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 That's right. That's right. That's right. That's right. Right. Yeah, yeah. Well, that's I think that's why this is good for academia, because I think an academic will create those protocols, right? This is like at the bleeding edge, right? That was my point of the slide, is like, I don't know that anyone has figured this out, and I don't think the answers to these questions will conclusively and carefully come from industry. And I think if what you are looking for, to my earlier slide about like, oh, what is the role of academia? It is not this field specifically, but fields like this one that synthesize disparate existing technical fields and look at the way they intersect and interact with humanity writ large, and carefully study those interaction patterns. And I don't know the answer to this question. And right now it seems very early. And so there's a bunch of like, I don't know, PhD students and honors students. If you want a topic, maybe pick something tractable from here. Yeah, okay, cool. Yeah, thank you so much.